Alright, in this video we will continue to learn about right triangle trigonometry. I'm talking about sine, cosine, and tangent defined for the acute angles in a right triangle, such as these. Now, in this video we're going to focus on solving right triangles. When I say solve, that means find any unknown angle or unknown side. So typically, there will be three things we have to find. Either we're looking for two sides in an angle, or maybe we'll be looking for two angles and a side. Usually there will be three things. In this one, we're looking for an angle and two sides. So there's usually three missing pieces that we need to find. Okay, and we're going to do 6 of these. Okay, so let's dive in and solve the triangle in number 13. And the directions say round the answer to the nearest tenth, so 1 decimal place. So looking at number 13, we are missing 3 things that we have to find. We have to find 2 unknown sides and 1 unknown angle. Let's start with this unknown angle right here. Well, these angles have to be complementary. We've already got 90 degrees right here, so the other 2 angles must add up to 90 degrees. So that means if I want to find this angle, all I have to really do is subtract from 90. So I can just do 90 minus 45, and that'll give me the other angle. So that turns out to be 45 degrees. Interesting. So actually we could use our special triangle knowledge, or we could use tangent, sine, and cosine. Anyway, we found one of the 3 things we need to find. Because we notice that this is a 45, 45, 90 triangle, that means it's going to be isosceles. Alright? See that these are base angles of an isosceles triangle. So these 2 sides over here should be equal. So if we find one, we found them both. Okay, so how will I do it? Alright, let's find, let's say if we call this x right here. Let's find x. So we could use tangent, sine, or cosine for this. So if we focus on the angle that we were given right from the start, so looking at the x and looking at the 12, are either one of these the hypotenuse? Yeah, the 12 here is the hypotenuse. Okay, so let me just jot that down. So 12 is the hypotenuse. Now what about this x right here? What's that? Is this the opposite or adjacent leg? Well, look how close it is. This is definitely the adjacent leg. Adjacent means right next to. The opposite leg would have been over here. So we've got adjacent and we've got hypotenuse. So which trig function is that? Well, the cosine of an angle is adjacent over hypotenuse. Okay, so let's go ahead and set that up. So the cosine of an angle, the angle is 45 degrees. So cosine of 45 degrees is the adjacent leg, right, which is x. Alright, I called it x, over the hypotenuse, which is 12. So it's just a matter of solving this and we'll have our missing piece. We can solve this by multiplying both sides by 12. Okay, so if I multiply by 12 on the left and the right, that way these will cancel out. So that's just going to give me the answer. That's going to give me x equals, and I can just put 12 cosine 45 in my calculator. So 12 cosine 45. Okay, and they're giving me that it's 6 radical 2. So that's a nice exact answer. 6 radical 2. Okay, so that is the answer, but if I want a decimal, because it does mention decimals, I can just toggle it. So that's 8.5. Got to round up. Okay, so x is 8.5. Okay, so that's right here. In fact, rather than saying x, maybe I'll say QR. Okay, QR, because I just made up that x. That wasn't part of the original problem. So I'll go back and I'll say QR is 8.5. Okay, so we found two things so far. Alright, we found the measure of angle P, which was 45 degrees. And we found QR. We also need to find PQ. So let's go ahead and find that. Alright, so PQ, I'm going to call this Y over here. So let's forget about X for now. Alright, of course 12 is still the hypotenuse. Alright, now from the 45, this Y is opposite. Okay, this is the opposite leg. So I've got opposite over hypotenuse then. Alright, opposite over hypotenuse, that's the sine function. So if I'm going to go for that, then I'm going to write this down. Sine of 45 degrees is opposite leg over hypotenuse. So that's y over 12. Okay, so to get y by itself, again, I would multiply both sides by 12. Okay, like this. Okay, there's no more room over here. I guess I gotta go like that. Alright, so these will cancel each other out. So that's just going to give me the answer, y equals 12 sine 45. So 12 sine 45. Oh, look, 6 radical 2 again. So y is equal to 6 radical 2. Now remember, this y is really PQ. So I'm going to go ahead and recognize that that's the same thing as before. And, you know, again, we knew that they would be the same. So PQ is also going to be 8.5. Okay, because you could toggle it, just like before. Alright, so we solved it. And that's how you solve it. Let's do a couple more. Okay, so on this problem, we're given two sides. Now, there are three things that are missing. We need to find the measure of angle P, and we need to find the measure of angle N, and we need to find the length of PN. So that's 3 missing pieces. Now, when you're given 2 out of 3 sides of a right triangle, you don't need tangent, sine, or cosine to find the missing piece. What you need is good old Pythagorean Theorem. So let's just do that. So let's see. I'll call this h for hypotenuse, since that's what it is. So remember how we could do a squared plus b squared equals c squared. Alright, so that would be, for the Pythagorean Theorem, that would be 12 squared plus 17 squared is equal to h squared. Alright, a squared plus b squared equals c squared. Okay, let's see. So 12 squared, 17 squared. So this is 144 plus 289 is equal to h squared. Right, 12 squared, 17 squared. Okay, that's where I'm getting those numbers from. Let me bring this back over here. Okay, if I add those together, 144 plus 289, that's 433. So I have 433 is equal to h squared. So if I want to find h, I will take the square root of both sides. Okay, so that is going to give me h equals, alright, so square root of 433, toggle it, 20.8. Okay, so I called it h just now, but really it's pn. So when you write your final answer, put it back in terms that you had to start off with. So far I found that the length of pn is 20.8. Okay, 1 down, 2 to go. Alright, now what will we find next? So now we need to find one of these angles. Let's go for angle P next. Okay, now remember, if you want to find an angle and you don't have any, what you're going to use are inverse trig functions. So let's see. The two numbers I have are 17 and 12. Are either one of these the hypotenuse? Now that was the hypotenuse right there. So neither one of these are the hypotenuse. That means they're opposite and adjacent. Okay, look at these guys. Alright, that's 17. See how far away it is from P? That makes this opposite. That makes this 12 adjacent. Alright, opposite and adjacent. So what function is that? That's the tangent function. So I will do this. I will say the tangent of this unknown angle P is opposite over adjacent. So 17 over 12. Now if I want to find the measure of angle P, I will do the inverse trig function. So that will be the inverse tangent of 17 over 12. Okay, so that means the measure of angle P, I can just put this in my calculator. So inverse tangent, what was it, 17 over 12. Okay, that is 54.8. Okay, so that's the second thing we've found. So we just found that the measure of angle P is 54.8. Okay, now we could find the measure of angle N in the same way by doing the tangent function all over again. However, if we're very confident of our measure of angle P, then we can sort of use a shortcut and just subtract from 90, right? Because if angle P here is 54.8, then these two angles have to add up to 90 degrees. So what I could do is I could just go 90 minus 54.8. And that's how I could get this. So 90 minus 54.8. So that's going to give me 35.2. Okay. So that would be the third and final thing. The measure of angle N is 35.2. Okay, so we have now solved the triangle for number 14. Alright, let's do one more of these, and we'll call that the end of this video. So for number 15, one more time we need to solve this triangle. And there are usually 3 pieces of information that we are missing. So what are those pieces? We're missing an angle right here, and we're missing 2 sides here and here. So these are the 3 things we need to find. The easiest thing to find is the missing angle. So let's just get that out of the way right now. These 2 angles are complementary. They have to add up to 90. So if this is 70, then this one must be 20. Okay? So that was pretty simple. So I'm just going to write that down in my collection. So the measure of angle U is 20 degrees. All right, 1 down, 2 to go. So now I need to find the 2 missing sides. Okay, so let's see. I will find, I'm going to find this side first. Okay, put an X here, but I'm finding UT. Okay, so looking at this X I just wrote down, looking at the number, the number that we're given, and I'm just going to stick with the angle that we're given instead of using the 20, which I could use. But I like to use the numbers that they gave me in the first place as much as possible. So looking at these 3 things, are either one of these the hypotenuse? Well, yes. The 15 is the hypotenuse. Let's label that up. That's the hypotenuse. What about X then? Is this opposite leg or adjacent leg? Remember, we're saying from the 70, okay? So from the 70, this is the opposite leg because it's across from. The adjacent leg would have been right here. So we're dealing with, we're looking for the opposite leg, and we're given the hypotenuse. Opposite and hypotenuse. Which function is that? That's your sine function. Okay, so let's set it up. So we will say the sine of 70 degrees, all right, that's opposite over hypotenuse, so that'll be x over 15. All right, to solve this, we just multiply both sides by 15. So those would cancel out. So that would give us x equals this, so 15 sine 70. Okay, and so rounding to 1 decimal place, that's 14.1. Got to round up. Okay, so I called it x, but really it is UT that I just found. So that's how I'm going to record it. So the length of UT is 14.1. Okay, 2 down, 1 to go. Alright, the thing that I still need to find is this missing side over here. I'm going to call it y. Okay, so I can forget about x for right now. I'm just going to erase it. Alright, I'm going to erase that too. Okay, so 15, that's still the hypotenuse. Now this y that I'm looking for now, is this opposite, adjacent? Well, it's not the hypotenuse. Is it opposite or adjacent? Well, clearly this is adjacent leg. Because look how close it is. It's right next to the 70. So we have adjacent leg and we have hypotenuse. Adjacent, hypotenuse. That's your cosine function. So that's why we are going to write cosine of 70 degrees. That's adjacent leg over the hypotenuse. So that's y over 15. Okay, so to solve this, I just need to multiply both sides by 15. Okay, so those would cancel out. So that is going to give me y equals 15 cosine 70. So that is 5.1. Okay, now I called it y, but this is really side ST. So that's how I'm going to record it in my final answer. Okay, so ST here is equal to 5.1. Okay, that's it. We found the 3 missing pieces. We have solved this triangle. Alright, that's going to do it for this video. Alright, if you want even more practice of doing basically the same thing, alright, we're going to do a few more of these in the next video. We're still solving triangles, but there will be a few interesting twists that will show up. So I'll see you on that next video.